So today we're looking at significant figures and accuracy, okay? So we don't always know how accurate something is, and most of the time we can't be really accurate. If I go and measure my weight, I'm only going to be as accurate as the thing that I'm using to measure it. Because obviously there could be decimal places going on forever if you really wanted to, if you have something that is really accurate, okay? So there is some sort of estimation going on, okay? So that's what we're going to be talking about today. Some examples of the way we approximate, as I just spoke about, the height and weight depending on what you're using. If I go and stand on something that's used to weighing how heavy cars are, obviously it's not going to be too accurate, okay? It might be, to the nearest 10 kilograms, because that's all that it matters, okay? So that's the sort of thing we're talking about today. Also, when we're describing how many people are at a football match or a soccer match, we're not going to necessarily know, but we can approximate. Maybe it's to the nearest 1,000 or the nearest 100, okay? So that sort of thing. All right, so the first thing we need to know is significant figures. There's a few little rules to follow, and I'll go through those rules and then we'll do some examples. The first thing is digits that are significant are all non-zero digits, zeros between two non-zero digits, trailing zeros after a decimal point, and all digits written in a number using scientific notation. So that's 4.2 times 10 to the power of 6, which we're not going to get into too much scientific notation, but it's important to have it down there when we come across it later on. The first example that we need to look at is these first few are how many significant figures are there in these following things. The first one, we count each one. So if I think about this, the first one, I basically start at the left and go along and count how many are significant. So I've got one there, I've got one there. Even though it's zero, it's between two significant numbers. So then I've got 3, then I've got 4, then I've got 5. Okay, so I have 5 significant figures in that one. Okay, this next one, I don't count that 0 because it's I go from the left until I hit a significant figure. I get the 6, I get to the 6 and I count that as significant. The 0 is going to be significant because even though it's after the decimal place, it still counts as significant. All right, then I've got the 4, then I've got a 6. So I have 4 significant figures there. The next one, I go along until I hit a significant figure. I've got the 3 there, and then I've got the 2, so I have 2 significant figures there. All right. The next one, I have 1 there, 2, 3, and 4. I count all of them. I have 4 significant figures there. This next one, I've got 1 here, 2 there, 3 there, 4 there. Even though that 0 is at the end, I am going to count it because someone's taken the time to write it down. Think about it that way. If they've written that down, that means that number is significant. So I have 5 significant figures there. The last one, I've got 1, 2. Because it's before the decimal point, I don't necessarily count that one, but we need to consider that it could have been exactly, say it was kilograms, it could have been exactly 2,500 kilograms. Or we could have rounded it to that. So that one's a bit tricky, and we say it could be 2, it could be 3, 1, 2, yeah, it could be 4 significant figures. So some questions might say, what is the smallest number, or what is the largest number of significant figures that could have been involved in that one? So that's a little bit of a tricky one. There are 2, 3, or 4 significant figures there. We need to know a little bit more information, maybe what was used to measure it, okay? The next one is, just like decimals, we're going to look at the number after the significant figure and we're going to raise the score of that one. So the thing I use is, if it's 5 or more, raise the score. If it's less than 4, we just cut things off and ignore it. So this is round the following to the whatever's in the brackets. So I want 2 significant figures on this first one. So I look at the third number, the third significant figure. This is going to be my first significant figure. Second, I'm looking at the third significant figure. Is it 5 or more? Yes, it is. So I've got to raise that second one. So that means I'm going to end up, I'll leave it at red, and then it's going to be 14. But I've still got to put zeros in there because 14 isn't an approximation for 136,482. So I'm going to be writing 140,000, sorry, 140,000. Okay, so I'm looking at that number after and then raising it or not. and I need to finish. I've obviously got rid of that number there, 3, 2. I'll put some more numbers in there. This one wants it to 3 significant figures, so I go along until I see one. I've got 1, 2, 3. I look at the 4th number. Is it 5 or more? No, it's not, so I leave it alone. This is important. I need to put all those numbers there, and it's like I just drop off the 4. I just ignore it. Just like rounding in decimals, it's exactly the same. Next one I want to be 3, so I've got 1, 2, 3. I look at that 4th number, and is it more than 5? Is it 5 or more? I raise the score of the previous one, so that'll get me to 3.25. 325. Now importantly, I don't write 0.0, because by writing that 0.0, that means I'm writing it to 4 decimal places. So I don't write that there. The next one wants to 2 decimal places, so I look at 1, 2, I look at that 3rd, it's kind of like I draw a line there, I look at that 3rd, is it more? So yes it is, I raise the score of that 1 in front of it, which is 31, and then I fill in with zeros after that. All right, again, I don't put decimal places because that would indicate that I've got numbers after that. The next one I want to 2 decimal places. I ignore all those zeros at the front because I've got to go until I hit a significant figure. I go 1, 1 there, 1 there. I look at the 3rd one, it's a 0, so I'm now going to ignore that. So I'm going to put all those zeros back down there and then put 4, 6. Okay? The last thing we're going to look at is how accurate our measurements are. Okay? We can't always be accurate, so we've got to be as close as we can. And sometimes we need to look at what the upper amount it could be or the lower amount, okay? So that's what this little diagram is here. This is what my measured amount is. It could have been a little bit more, it's going to be a little bit more or a little bit less, just depending on how accurate I am, okay? So it's that uncertainty range that we're trying to make sure that error that we're talking about, okay? So it's the smallest, and what it's defined as is the smallest unit that's being used. So for example, if I've got, if I'm measuring in meters, okay? My smallest unit is meters, that's being measured in meters, so therefore it's going to be half a meter or 0.5 of a meter, okay? If I'm measuring it in centimeters, my smallest unit that I'm measuring something, my tape is the smallest unit that I can do is centimeters, so therefore it's going to be 0.5 centimeters, or I could write 5 millimeters. Generally we tend to write the units that we're smallest one that we're measuring in, even keeping it at that half just for consistency, okay? So the questions that we could come across here are, what are the upper and lower bounds? So this comes back to up here. So this is what we're looking for here. We're looking for these upper and lower bounds. What's the largest it could be? What is the smallest it could be? If I've got something that I said was 10 meters, so therefore my smallest measurement is meters, so that means it could have been half a meter more or half a meter less. So my upper limit is 10.5 meters and my lowest one is going to be 9.5 meters. All right. So if I look at this, I've got $2,500 and I've got it, and that's to the nearest 100. So my lowest unit was $100. So therefore my the smallest half of that smallest unit is $50. So my upper boundary is going to be 2,550. I've added 50, that's half of that unit. So my lower one's going to be 2,450. I take $50 off because that was half of it, okay? And that should be $100 there, to the nearest $100, okay? If I've got something that measures 2.35 centimeters, my lowest unit is centimeters. So therefore my half is, but this one's a little bit tricky and I put it in there for a reason. It's kind of like my lowest unit was 0.01 of a centimeter. So half of that is 0.05 centimeters. So I've got to add that one onto this. So my upper limit is going to be 2.355 centimeters and my lower boundary is going to be 2.345 centimeters. So that's sort of the extension question there. That's a little bit trickier and you might need to think about that one a little bit more. So go back and just think about those. The last question is, the soccer field is made 100 meters plus or minus 0.5 of a metre. So they're giving you that half a unit already, meaning that, so what is the smallest unit of measurement? They've already halved it, so therefore the smallest unit is going to be 1 metre. All right, they've already told you that that error, this part here is my error. That's what that half of it's going to be. All right. Thanks very much.